In this presentation, you will watch two examples of performing long division of a polynomial. A prerequisite is you recall how to perform long division using numbers. The first step is to set up your long division problem as you would if you were doing long division with numbers. Here is your divisor, x minus 2, and here is our polynomial, 6x cubed minus 19x squared plus 16x minus 4. In polynomial long division, your goal is to eliminate this first term, 6x cubed, by finding a value in the quotient that when you multiply that value in the quotient times the divisor, x minus 2, you obtain 6x cubed. That value is 6x squared. We multiply and we obtain 6x cubed minus 12x squared. Subtract, we now have negative 7x squared. We drop the 16x down and we have plus 16x. We now want to eliminate negative 7x squared by finding another value in the quotient that when we multiply that times x minus 2, we obtain negative 7x squared. That value is negative 7x. Perform the multiplication. We now have negative 7x squared plus 14x. Again, subtract. We now have 2x minus 4. We drop down this negative 4. We need a value in the quotient that we multiply it times the divisor. We obtain 2x. That's 2. And now we have 2x minus 4. We subtract, and our remainder is 0. In most cases, your remainder will not be 0. Let's now review the names of the parts of our division problem. As I've said throughout this presentation, this term is referred to as the divisor. The part underneath the division symbol is the dividend. Our result is called the quotient, and what's left over is referred to as the remainder. We're now going to check our result, and to be sure that we perform the division properly, we use the division algorithm to check our solution. The division algorithm states that the dividend, which in our case is the polynomial, equals the divisor times the quotient plus the remainder. For our problem, there's the dividend, the divisor times the quotient plus the remainder. If we expand out the multiplication of the divisor times the quotient, we obtain these terms. I recommend that you pause the video, perform this expansion on your own, and compare it to the correct result. Combining like terms, and we do have both sides are equal, therefore our division problem has been done correctly. Here's an example for you to try. I would pause the video, try this, and then compare your result to the answer on the next slide. You should have obtained this. In our second example, I want to point out that sometimes not every term of a polynomial is in the polynomial. That's because here we're missing an x cubed term, and the coefficient for that term was 0. We just don't bother writing it. However, when we perform the division, we must account for any missing terms in our polynomial. Otherwise, we'll obtain an incorrect result. Let's go ahead and perform this division. I'm going to step through this a little more quickly. First term would be 2x cubed. Multiply that times the the divisor. We obtain 2x to the fourth minus 6x cubed. Subtract, we have positive 6x cubed minus 8x squared. Multiply the divisor by 6x squared. We obtain 6x cubed minus 18x squared. Subtract, we now have 10x squared. Drop the 5x. Multiply the divisor by 10x. We obtain 10x squared minus 30x. Subtract, we have 35x dropping down the negative 7. We multiply the divisor by 35, and we have 35x minus 105, so our remainder is now 98.